Okay, so let's look at this problem. I've put the two columns out back in what's usually the normal order. Let's notice that we have a discrete probability distribution. And we know it's a discrete probability distribution because all of the numbers over here are counting numbers. They don't have decimals or fractions in them. Okay, so with that, I'm gonna write out our formula for the variance for a discrete probability distribution. And remember that it was the sum of x squared px minus the mean squared. And then I'll also write our formula for the mean of a discrete probability distribution, which is the sum of the xpx's. Okay, so when we keep that in mind, we need to get this mean, and then we can get our variance. Okay, so I'm going to go back to getting out of the draw feature, and let's get the sum of the xpx's first so we can have the mean. All right, so first I need to get x times px. So I'm going to multiply this column times this column. So 1 times 0.25 is 0.25. 3 times 0.05 is 0.15, except I can't seem to type. 10 times 0.45 is 4.5. 11 times 0.1 is 0.11. I'm sorry, it's 1.1. I misplaced my decimal. Here we go. And then 12 times 0.15 is going to give us 1.8. And then we get the sum of this column to find our mean. So I'll go ahead and write this out. Our mean is the sum of this column. So if I add 0.25, 0.15, 4.5, 1.1, and 1.8, that sum ends up being 7.8. Okay, so that's getting what we need to plug in right there. All right, so now let's go back and let's get the sum of the x squared px's. All right, so the first thing I need to do then is to get x squared. So I'm going to go back here to my x column, and I'm going to square each item. So squaring 1, that's 1. Squaring 3, 3 times 3 is 9. Squaring 10, 10 times 10 is 100. Squaring 11, that's 121. And squaring 12, that's 144. And now I want to take this column and multiply it times the P of X column, times the probabilities. So 1 times 0.25 is 0.25. 9 times 0.05 is 0.45. 100 times 0.45 is 45. 121 times 0.1 is 12.1. And then 144 times 0.15 ends up being 21.6. All right, and now I want to add that column up and get the sum, and that's what's going to go in the first part of my formula. So I'm going to go ahead and write down. So if I add up this column, that answer ends up being 79.4. And let me kind of make that a little longer. And then I want to subtract off the mean squared. So 7.8 squared. All right, and if we put this into our calculator and let our calculator do 79.4 minus 7.8 squared, we end up getting 18.56 as our variance. And realize if this asked for standard deviation, the only thing further that we would have had to do is take the square root of 18.56 and we'd have had the standard deviation for this discrete probability distribution.